Welcome to our third video in our Year 10 Chem 1 revision section, and this video is on chemical reactions. So during this section of the course we talked about the fact that we can get word equations which have our reactants on the left hand side and our products on the right hand side. We talked about the fact that we only have arrows and pluses in a chemical equation. Okay, and we talked about the fact that we can then write that as a simple equation which is balanced. Okay, so we looked at balance and equations. When we talked about balance and equations, we said that the coefficients here, they're the only things we can add. We can't change the number of atoms in the molecule. So for example, O2 means there's 2 oxygen atoms in that molecule. We can't make that O3 because then we make a completely different molecule. But during balance and equations, we can change these coefficients. So we change the big number. Here we have that the chemical reaction to make water. Okay, and we're looking at the atoms. So we can see on this side, we've got 4 hydrogen atoms, okay, and we've got 2 oxygen atoms. They're in a molecule to make 1 molecule of oxygen. These are in 2 molecules to make 2 hydrogen molecules. But we need to ensure we have the same amount of atoms on the other side. So we've got 4 there. We've got 1, 2, 3, 4. Now if we look at this, H2, so that means 2 atoms. And then that 2 means we've got 2 of the whole molecules of oxygen. So for hydrogen, we've got 1, 2, meaning that 1, 2. We've got 2 of them. Oxygen, that says we've only got 1 oxygen, but because we've got that there, it's saying we've got 2 oxygens. So it's the coefficients that say how many molecules there are. It's the small number that says how many atoms there are. Now we talked about these symbols of state and that sometimes in chemical equations you're going to see them. So you've got your solid, you've got your liquid, you've got your gas, but more importantly here you've got your aqueous substance, okay, and that means it's dissolved in water. So we had steps for writing our balanced equations. Sorry, these are not animated to come up one at a time. So first of all, you write your word equation for the reaction. Then you write the formula for each of the reactants and products. You use your coefficients, so that number in front of the formula, to balance either side. You check that the number of atoms on both sides are balanced, and you include the symbols for the states of matter for substances involved. Now, how do you know if a chemical reaction has occurred? Well, one of these things may occur. You may get the formations of precipitate, so that's solid in the liquid. You may get a permanent colour change. You may get some gas produced or a new odour. You may see an increase or decrease in temperature, or you may see an emission of light. Now, we also looked at how we classify these chemical reactions, and we said we had decomposition reactions, our synthesis or combination reaction, our single displacement reaction, our double displacement reaction, and our combustion reactions. We also did mention precipitation reactions and neutralization. So neutralization, we said that was that where you add an acid to a base or an alkali, and it gave us a salt plus water. We said our combination reaction, where you've got reactant A and reactant B, and they join together to make that new reactant. So for example, with water, where you have hydrogen and oxygen bonding to make H2O. We had decomposition, and we can see the breakdown of water here. We start off with water, and it breaks down into its individual substances that have produced it. We have our combustion reaction, okay, and this is where we need that activation energy of heat along with oxygen, okay, to cause the products of, or to form the products of carbon dioxide and water, okay, and saying that our fuel has to be a hydrocarbon in our combustion reaction. We have that single displacement reaction, so you've got A and B over here and C. So remember, in my class we talk about people dancing, so we've got A and B dancing and we've got C dancing, and then in our products A's left on their own and B and C have started dancing together. So B has swapped from one reactant to the other. That double displacement where both swap, so if you look at this, we've got A and B, and we end up with A and C, and then we've got C and D, and we end up with B and D. So the products are a complete swap of the reactants. And then our precipitation reaction we talked about was when we ended up with that aqueous solution. And that, guys, is the final video for your revision series. I hope they have been useful.